Now it's on. All right, 2 cubes shown, proportional. All it means we see proportional just means there's going to be some scale factor between them. Edges of the larger cube are 3 times the edges of the smaller cube. So what does that mean our scale factor is? 3. So scale factor is 3. And that means this one's a little bit different. Usually we try to put the original on the left side, but if our scale factor is 3, that means that this is the original and it's going to become a larger shape. The volume of the, yes, this is going to be the original. This is going to be the new. We want to know what is that new volume going to be? So we write down our formula. We say that the new volume is equal to the original volume times what? Scale factor cubed. Why cubed?
Because we're doing volume.
Because volume's in 3 dimensions. So our original is 100 times our scale factor, which is 3 cubed. 3 cubed is 27. 27 times 100 is, so what is our new volume? How about this one? All right, good.
You're clear from B2 to
Okay. A distributing companies is 2 cylinders. Smaller cylinder has dimensions that are 1/3 the larger cylinder. So a lot of people are getting confused by this. If this shape is 1/3 of the bigger shape, how can we say how many times bigger this larger shape is than the smaller shape? It's 3 times as big. So depending on whether or not you want to do fractions, how many people love fractions? Okay, how many people would rather not do fractions? Okay, so could we look at it, instead of saying that the scale factor from big to small is 1/3, can we say the scale factor from small to big is 3? Because it's the opposite of 1/3.
Doesn't it have to be cubed?
What if the fractional is 2/3?
Then it would be 3/2 as big.
I thought 1/3 was 30. What if it was 1/4? That'd be 4.
1/4 is
4.
4 times.
Just think of how they're over.
They're just flipped. Like if I said this was half the size of this one on the left, how many times bigger is this?
2.
It's 2 times as big. Okay? So if this is 1/3 the size, then the bigger one is 3 times as big as the small. Okay? So now it's just like the last one. So we have new equals original times scale factor cubed. Our original amount is now 20 times 3 cubed. 3 cubed we keep saying is, so we have 27 times 20, which is 540. And that'd be inches cubed. Okay. If we did it the other way, it would involve dividing and fractions. That's, yeah. Anytime you can make it with whole numbers and multiplying, you're probably better off. All right, number 3. Here's another good one. Yeah, they're going in order. Shipping company sells 2 types of cartons that are shaped like prisms, blah, 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 blah. Larger carton has a volume of 1680. Smaller carton has dimensions that are half the size of the larger carton. So what can we say our scale factor is?
1/2.
Is 1/2. Now the reason we wouldn't switch this one around is because we want to consider the number that we know to be the original.
So we just divide.
So-
1480 was out of them two.
Right. So now we have same formula. We're still looking for volume. So the new volume is still the original times scale factor cubed. Our original is 1680 times 1/2 cubed. That might be it. So 1/2 times 1/2 times 1/2 is 1/8.
So you divide it by 8 then.
Right. So this is 1680 times 1/8. Yes, that is 1680 divided by 8. If you're not sure why that is, you can always multiply straight across first and get 1680 times 1 is 1680 over 8. And then you have a fraction, so to simplify a fraction you use TIBO, which is top in, bottom out. And that looks bad because it's like, oh, that's a 4-digit number, but 8 goes into 16 twice. That cleans up. 8 goes into 8 once. That cleans up, and we just have an extra 0. So our volume is 210 cubic inches. Thank you. Inches cubed, or cubic inches. Right? Square pyramid with a volume of 80 cubic feet has dimensions changed by a scale factor 1/2. This is just the same as last one. Our scale factor is still 1/2. So again, we say new equals original times scale factor cubed. Our original amount is 80. Our scale factor is 1/2. So just like last time, these fractions don't change. You're going to see them again and again. 1/2 cubed is 1/8. So we have what's 1/8 of 80?
10.
Or 80 over 8, which does equal 10. 80 times 1. So once you start seeing enough of these, you can start to recognize patterns. Like if we say, change the volume and the scale factor is 2, what are you going to multiply your original by? What did you say? 8. So if you can start remembering that, if you just know, oh, well, 2 cubed is 8, when it multiplies by 8. If the scale factor is 1/2, we've seen it 2 problems in a row. Really, what are we doing with our original amount? We're just dividing it by 8. Okay? So that's why we keep doing the same examples over and over again. So you see, it's like, oh, all these problems really aren't that different. In fact, I'm really bored with this. I wish Mr. Ellis would give us harder work. Okay, so this one's a little bit different. So it says volume of the larger prism is 1,000 V equals. The smaller one is volume of 125. So this time it says what is the ratio of the heights, which really that's just a fancy way of saying what's the scale factor. So to find that, we have to figure out at what rate is our volume changing. So is it going down?
Yes.
Yeah, so we're dividing by something, but what? So what is 1,000 divided by 125?
Oh, so that's how you figure that out.
4.
It's like 9 or something.
This is 8.
8, yeah.
8 times 125 is exactly 1,000. So what that means is since we're dividing this by 8, that means that one of our key numbers is 1/8. But is that the scale factor?
No, there's no cube that.
Not quite. This is the scale factor that's already been cubed. Because this is the difference, not in the side lengths, but the entire volume. Okay? So we're just working backwards. It's just the opposite of what we did in the previous example. So now you got to think, what number times itself 3 times equals 1/8?
Oh, 1/2.
So first of all, we've seen it in the last 2 examples here. Or we could also say, well, 1 times 1 times 1 equals 1, and 2 times 2 times 2 equals 8, which means our scale factor here is no. Yes.
Oh, so you basically are dividing it by 2.
No.
I mean, 2 by 2. So you would like do like 8 divided by 4.
No, don't ever think of it as dividing. Has this been off the whole time?
No.
Okay.
How do you know when to multiply and divide? How do you know?
For this part, or that it was going to be 1/8 and not 8.
For the over there.
Knowing why to do this, the reason we do all this is because we need to know how do we get from here to there. Right? Because with scale factor, we're always multiplying by something. So you think, what number times 1,000 equals 125? And that's where we get 1/8. Okay? Not so bad? Not too bad? All right. Some of these you may have seen yesterday. So, hopefully. What?
Is this a test?
Some of them. No.
We're doing this with our partner.
All right. A volume's prism changed from 10 to 80. Describe the proportional change and the prism's dimensions. All this means, this is a real fancy way of just saying, what's the scale factor? Okay? So our volume went from 10 to 80. So we think, at what rate is it growing? How do we get from 10 to 80? Times 8. If you don't know that, we can work backwards and say, what's 80 divided by 10? And that's... So does that mean our scale factor is 8? No, that means that what is 8? That's a scale factor cubed is 8. So we just have to think, what number times itself 3 times equals 8 is still 2? Which means our scale factor is... So that's what I was talking about. Anytime you see it's like, oh, the volume increased by 8 times. So I know the scale factor has to be 2.
Wait, is it 2 or 2 cubed? It's 2.
It's 2. Okay, that's it. So that is the change in the dimensions, is just the scale factor. right, number 2. A 10 by 9 by 12 inch box enlarged by a scale factor of 3. How many cubes of volume of 10 inches will it take to fill the larger box? All right, 2 ways we can do this. We could either, if we have a box here, this is 10 by 9 by 12. We could either find the volume of the original box and then use the scale factor, or we can draw a new box using the scale factor that it gives us. So we could say, if this is a bigger box here, let me just assume it's bigger. Whatever. What would the new side lengths be?
30.
It'd be 30, because 10 times 3 is 30. 27, 9 times 3, and 36. So now how can we find the volume of that new shape? We just multiply. If we know, we can go back to our formula. And then the area of the base is length times width. Excuse me. So this is 30 times 27 times 36. So you could work that out. Or, no. We could find the volume of this shape over here. So this is 10 times 9 times 12. So that's 90 times 12.
Because 9 times 12 is 81, so then times 10 would be...
I'm going to say I don't think that's right. I mean, it might be, now that I think about it.
Yeah, it is. Or if it's not, 9 times 12 is 81.
I think it's 1080, though.
Yeah, it is 1080.
Okay, so now if we have this, we have the original, our new OG. So we have 1080, and our scale factor here is 3, right? 3 cubed. So what's 3 cubed? So we have 1080 times 27.
So you wanna know why people don't watch your videos to the end because they're too long?
Cool.
They are 50-minute length.
So now, either one of these you work out, whichever one you chose, should give you the same thing. And if anything, I'm willing to bet you that 30 times 36 equals 1080. Okay.
Very cool.
If you're right, I won't have to do
If you were right,
Oh, and then you. Oh, I didn't.
If you're right, we will do
if you're right, we will learn a lesson.
So what's 1080 times 27? All right, everybody else. 29,160. Thank you. So now, all right now. That's not the answer to the question, though. That is the volume, but it wants to know how many of these cubes that are each 10 cubic inches will it take to fill that large box. So this is a total of that many inches cubes. So to figure out how many of these little blocks we have to do, we need to divide it by 10, which really is not that difficult. We just move the decimal over one. So it would take 2,916 tiny boxes. Right? And another thing to point out, I think I said this yesterday, is just how quickly volume changes with scale factor. Like you think all it is We just changed it by a scale factor of 3. You think 3, that's no big deal. It's not that much bigger, right? Our volume went from 1,000 to about 30,000 just by increasing it by a scale factor of 3.
Why didn't they just get one big ball?
So something to keep in mind, anytime you're doing scale factor with volume, if you get a really big number, that's not an indication you've done something wrong. Okay? Okay. All right, number 3. Volume of cone was changed from 800 to 100 cubic units. Describe the proportional change in the dimensions of the cone. This one sounds really familiar. It looks an awful lot like that, except what's the difference between...
What's a cone? It's switch number.
It's not so much that it's cone. This shape is totally unimportant. That could be the volume of a ice cream truck.
There's no ice cream.
Okay? Because all we care about is the scale factor. This shape is completely irrelevant. But what's the bigger difference between this one and...
The numbers are switched. The answer is still 2.
So instead of it getting bigger, now it's getting smaller. So instead of timesing it by 8, now we're... Which means instead of our scale factor cube being 8, now it's going to be
2. Half. 1/3. 1/8.
1/8, which is the opposite of times 8. Okay? So now to find just the scale factor, what do we need to think about?
How many times does the number go into 1/8?
Sort of. We say what number times itself 3 times is equal to 1/8, which is still 1/2. That's why we made that chart the other day that had 2 cubed is 8, 3 cubed is 27, because those numbers are going to come up again and again and again. Okay. So what is our scale factor here? 1/2. That's what we're doing. We don't really talk about that in middle school at all. But yes, the cubed root of 1/8 is 1/2. Right? 2 more.
Well, technically we've already done that.
Hey. 4 by 3 by 2 centimeter box is enlarged by a scale factor of 4. How many cubes of the volume of 8 cubic centimeters will it take to fill the larger box? So what does this one look like? It's just like number 2. So again, kind of. There's really only so many problems you can make about scale factor with volume. So this is 4 by 3 by 2. We have a scale factor of 4, which means this is going to get a lot bigger.
Can you do sphere?
Yes, remember we said shape doesn't matter? We couldn't use these numbers with a sphere because it doesn't have that many numbers, but they could give you problems about spheres. All right, back to this. Could we find the volume of this original box? This is 4 times 3 times 2, which is 24. So that's our original. We keep going back to our formula every time. And I know we're writing all this down.
Wait, we're supposed to? Wait, I know.
The original times the scale factor, which is... So we're going to have 24 times 4 cubed. What did we say 4 cubed was? Oh, now you know what it is. You couldn't tell me yesterday when my boss was in the room.
We didn't get it. We didn't get it the first time. We were thinking,
What was she grading you on?
So now we have 24 times 64, which is some sort of number.
1,536.
Is that right? 16, 25, 6, 3, 5. So our volume is 1,536. Is that our answer? No. What do we have to do with that? Why do we divide it by 8? Because the question is not asking you what the volume is. It says, how many tiny cubes of the volume of 8 cubic centimeters will it take to fill that up? So our very last step is to say, what is 1536 divided by 8?
How many times a day going to
192.
Yeah, everybody's got the answer.
I don't got the answer.
192.
This is 1.
292. 9. Got it right.
So it takes 192 tiny cubes. Those are boxes?
Oh, no, it's
How many cubes? Yeah.
When Lego cube of box.
Yes.
not math. Tiny cubes.
All right. The last one.
We've done it.
We did all this?
Yeah, we've done that. That's the one. That's B5.
For realsies?
Or A5.
Well, let's...
That's A5. Yeah, that's A5.
All right. So number 5. We need to fill in the table. So if we haven't, this is going to be the original. So to go from original to new, we have to take the scale factor cubed. So 2 cubed is 8, which means to find the new volume, we'd have to take 100 times 8, which is 800. Put it somewhere.
Wait, so we already did that.
Yes.
Mr. Ellis, how do we know if it's been used up?
What is that? Wait, why did you do 2, 2, 3?
Is there one?
Because if we need to change the volume, we don't just multiply by the scale factor. We always multiply by the scale factor cubed. Okay? Let's try the other ones that are set like this. So what about the cylinder? So this one's trickier. We haven't done one like this, but that's okay because math's fun. So we have a scale factor of 2/3, so we would need to
Change it into a decimal.
cube that. So 2 to the third is not 6. 2 to the third is 8. Over 3 cubed, which is...
27.
So now what this works out to is this is 27 times 8 over 27. Now we could multiply this out, but if we think about this, and you actually have to think about this, if we do 27 times 8 and then divide by 27, is that sort of going to cancel out? Yes, so if we see this, we can simplify fractions that are across. We can simplify diagonally. So 27 and 27 simplifies to 1 and 1. That makes it a lot easier to work with because now 1 times 8 is 8 over. So if we have a volume of 27 and a scale factor of 2/3, our new volume is just 8.
Mr. Ellis, how do you tell if a number if their scale factor needs to be cubed?
It always does. If you're doing volume,
Even like on number 4 on the other side, it says.
all right. So what we can do now, normally we would have skipped this one, but hopefully we can make a really easiest connection here. If going from 27 to 8 required a scale factor of 2/3, what scale factor do you think it's going to take to go from 8 up to 27? Remember we talked about being able to flip it to go the opposite way?
3, 2.
There you go. So the same way that the opposite of 2 is 1/2, because 2 over 1, if you flip it, is 1/2. If we flip 3 halves, or 2/3, we could get the same answer only going backwards. And if you don't believe me, you can try that. You can take 3 halves and cube it and times it by 8, and you'll get 20. All right, that's what I like to hear. Chances are, though, first of all, they won't give you something this hard without it being multiple choice. So if they give you like really awful scale factors like this, just work them all out. I know I'm not supposed to tell you that, but if they give you ugly numbers, you have my permission. All right, how about this cone? It says our scale factor is 0.5. Have we done anything with decimals? No, so how can we rewrite 0.5?
1/2.
1/2.
Which is then 1/8.
And this is one of the few times where using fractions is a lot easier than decimals. Because 1/2 cubed is just 1/8. And so now we just need 1/8 of 6. So we say 6 times 1/8. Not quite 48. So this would be 6 over 1. So then 6 times 1 is 6. 1 times 8 is 8. Can we simplify 6/8 by 2, and that would give us, so what is our new volume? 3/4. You still get that. You could. But then you'd have to multiply 0.5 times 0.5 times 0.5. If you have a whole number and you need to write it as a fraction, you always put it over 1. Yes?
Is that thing that says 3 over 1, is that the answer?
Yes.
Are we going to do the last one?
I'm trying. But people keep asking me questions. All right. A couple more. We haven't had to do that much today, but that's okay. If we have, I'm going to erase some of this extra work. Hopefully you wrote it down.
No, okay.
Because it's kind of ugly now. All right, so if we have, let's start with our formula. We have new is original times scale factor cubed. Okay? But in this case here, we have the scale factor of 1/2 cubed. And do we have the original or the new? We have the new, so we have this one over here. And we still need to know what is this original amount. Okay? So we can work out 1/2 cubed, which is 1/8. So we have 1/8 of some number equals 16. So then let's think about it. Should that number be bigger or smaller than 16? Let's think. If our scale factor is 1/2, that means our shape is getting smaller, which means this number here should actually be bigger. Okay? So instead of multiplying by 1/8, what do you think we can do to 16 that'll give us this original number? We can times it by 8. So let's try it out. What's 16 times 8?
16
Is 128. And then if we think about that, if we were to take 128 and divide it by 8, what would that give us? 16, which is what we want. So what is our original volume? Is 128. Okay? So that's all you have to do. If they give you the new amount and you need to go back to the original, you just do the opposite of what we have here. Okay? Our last example is what do we do when it gives us the new and the original, but we need the scale factor? So again, we start with okay. So we have the new is 320. The original is 40 times some number. So what number times 40 equals 320?
8.
And if you don't know that, how could we find it? We divide. So we say, what's 320 divided by 40 is 8. So what that means is that our scale factor cubed equals 8. So the scale factor cubed is 8. What is our scale factor?
2.
Just 2. Because 2 times 2 times 2 is... Right? Don't put this away. Take the time remaining.